So we were talking about graphs last class. We're going to continue that discussion. Today we're going to talk about symmetry. So a graph can have three different kinds of symmetry. It can be symmetric about the y-axis, the x-axis, or the origin. So symmetric about the y-axis just means that the y-axis acts like a mirror. If you were to fold the graph along the y-axis, then the two pieces of the graph, this piece and this piece, would lie on top of each other. And then symmetric about the x-axis means that the x-axis is the mirror. If you fold along the x-axis, the two pieces, this piece and this piece, match. And origin symmetry means that we do both folds, fold along the x-axis, then the y-axis. So it's like you would be taking this little piece of graph paper and folding it into quarters. And if you do that, if you do both folds, then this piece will perfectly match this piece. You see it? If you do both folds, they would lie on top of each other. So we can look at a graph and say whether or not it looks like it's symmetric. Okay. Sometimes we don't have the ability to create a graph, and sometimes a graph can be deceiving. It can look symmetric and not actually be perfectly symmetric. So we have algebraic tests to tell us whether or not the graph truly is symmetric. So these are the tests. A graph is symmetric about the y-axis if its equation is unchanged when x is replaced with negative x. So reason being, these 2 points here, this point and this point, have y-axis symmetry. They're mirrors of each other over the y-axis. One point is x comma y. We go right x and up y. And the other point just went left x and then up y. So it's negative x comma y. So that's why the test replaces x with negative x, because x and negative x should give the same result if you have y-axis symmetry. They should give the same y value. That's y-axis symmetry. Yep. And then for x-axis symmetry, you replace y with negative y. We'll look at the picture again. So the 2 points in this picture that have x-axis symmetry are this one and this one. Both of those points have the same x coordinate, opposite y coordinates. So they both went over x, right? But then one went up y and one went down y. So if you replace y and negative y, replace the y with the negative y, you have the same x. So that's why the algebraic test for x-axis symmetry is replace y with negative y. And then for origin symmetry, oops. For origin symmetry, you replace them both, x with negative x and y with negative y, because if this is my original point, to create origin symmetry, you do both symmetries. Fold over x, and it would land right here. Then fold over y, and it would land right here. So this point went right x, up y to get to it. So to get to this point that's symmetric about the origin, you go left x and down y. So in the test for origin symmetry, you replace x with negative x and y with negative y. Okay, so this picture can kind of remind you what the tests are, what all three tests are. So we'll do an example of each test. So I have y equals the absolute value of x. So I want to test this for y-axis symmetry because I looked at a graph of it and I said it certainly looks like it has y-axis symmetry. Let's just confirm it with an algebraic test. Start with the equation and replace x with negative x. Replace all your x's with negative x's. So I get y equals the absolute value of negative x. Now, what is true about the absolute value of x and the absolute value of negative x? They're the same, yeah. The absolute value of 3 and the absolute value of negative 3 are the same value. So when I take the absolute value of negative x, that is the absolute value of x. So you can see that the equation remained unchanged. The original is not different from the equation when I replace the x with a negative x. So I have y-axis symmetry. When the equation remains unchanged, you have that kind of symmetry.
But it's always.
We'll see some more examples. I think it'll get clearer. Okay, so let's look at an x-axis one. Here I have the equation y squared equals x. I graphed it, or I had a computer graph it for me. It definitely looks like it has x-axis symmetry. So I'm going to confirm it with an algebraic test. So you do that by starting with the original equation, y squared equals x, and then you replace y with negative y. Everywhere there's a y, you make it a negative y. So instead of y squared, I'm going to do the opposite of y squared. But what is negative y quantity squared? Y squared. Negative y squared means negative y times negative y. The negative times the negative is a positive, and y times y is y squared. So that's unchanged. So replacing my y with a negative y did not change the equation in any way. So now I have x-axis symmetry. Okay, so now I have the equation y equals x cubed. I graphed it, had my computer graph it. It looks like it has origin symmetry, like if I did the two folds, the two pieces would match. So to test for origin symmetry, I replaced the x's with negative x's and the y's with negative y's. So instead of a y here, I put a negative y. And instead of cubing just a plain old x, I'm going to cube a negative x. What is negative x cubed equal to? Negative x to the third, yes. Negative x cubed means negative x times negative x times negative x. Negative times a negative times a negative is going to be negative. So this equals negative x cubed, because x times x times x is x cubed. And on the left here, I still have a negative y. Negative y equals negative x cubed. Is that equivalent to the original equation? Yes, how come? Yeah, if I put them both on the same side, the equation would look the same. I could, in this equation, I could add y to both sides and I would get y minus x cubed. And in this equation, I could subtract x cubed from both sides and I would get y minus x cubed. So you can think of it like that, or you can think of it as if I divided both sides of this equation by -1, I would end up with y equals x cubed. When you do the same thing to both sides of an equation, you create an equivalent equation. So these two are the same, unchanged. So origin, symmetry. So a big key to being able to do these kinds of problems is recognizing the difference between and negative x quantity squared and negative x squared. These are two different quantities, and this is something that you have probably seen in another math class, and if this still confuses you, the tests for symmetry are going to confuse you. Okay? Negative x in parentheses squared means negative x times negative x. It means you are squaring the entire thing, the negative x. Negative x squared means negative 1 times x times x. The negative doesn't go with the x. It's like a negative 1 times x squared. Yeah. Okay, so I have 3 examples here. We're going to test each equation for all 3 kinds of symmetry. I'll do one with you, and then I'm going to let you try a couple. So I have x equals y to the 4th minus y squared. I want to test for symmetry about the y-axis. So the test for symmetry about y is what? Replace the x with negative x. So instead of an x here, I'm going to write a negative x. Leave the y's exactly as they are. Is this equation that I just wrote down equivalent to the original? Is there any way I can manipulate it by moving things around, multiplying by negative 1, anything I can do to make it look like the original equation? No, because my original has a positive x. If I try to make this x positive by, say, dividing both sides by negative 1, I would end up with positive x equals negative y to the 4th plus y squared, which is now, I've changed the y side. So these are not equivalent. I have no y-axis symmetry. Okay, I replaced the x with a negative x, and my equation was different, became fundamentally different. All right, let's try x-axis symmetry. For x-axis symmetry, you replace y with negative y. So my original equation, x equals y to the 4th minus y squared. And I'm going to replace the y's with negative y's. So instead of raising y to the 4th, I'm going to do negative y to the 4th and negative y squared. What is negative y to the 4th? Y to the 4th. It's negative y times negative y times negative y times negative y. So 4 negatives are going to make a positive. And y times y times y times y is y to the 4th. And negative y squared is y squared. So is that equivalent to my original? Yes. So I do have x-axis symmetry. Okay, so now let's do the test for origin. Write down the original equation. Now I replace x with negative x and y with negative y. So I have negative x equals negative y to the 4th minus negative y squared. And you guys just told me that negative y to the 4th is y to the 4th, and negative y squared is y squared. And that's not equivalent, right? In our first test, this is the equation we got, and we decided it was not equivalent. So I have no origin symmetry. All right, so there's two other equations. I want you to work in your groups, test them for the three kinds of symmetry. Okay, so lastly, in terms of symmetry, you should be able to complete a graph if you know something about its symmetry. So this first graph on the left here is only partially drawn. I want you to finish the drawing knowing that it has y-axis symmetry. So there's kind of two approaches you can take. Some people are very good visualization people, and you can think of the y-axis as a mirror and just try to match it. So, nope, I messed it up. Like that. So you just try to mirror it. But that kind of visualization is not easy for everyone. So if that is difficult for you, you can use points. Okay? Use what you know about the symmetry over the y-axis. In the test, you replace x with negative x. So that's what we'll do with the points. Make all the x coordinates their opposites. Keep the y coordinates the same. So just pick a few important points. We'll just label a few important points. So sort of the corners. If they're all straight, then you just need the corners. And then you plot each of those points, but make the x values their opposite. So 0, 3, well, what's the opposite of 0? 0, so that one stays the same, right? That one stays the same. And then 2, 1, instead of plotting 2, 1, we would plot negative 2, 1. Use the opposite x value. And then instead of 2, negative 1, we plot negative 2, negative 1. So because this is y-axis symmetry, you replace the x's with negative x's. Instead of 3, negative 1, we'll do negative 3, negative 1. And instead of 5, 1, we'll do negative 5, 1. And then just connect the dots. The same goes for origin symmetry. Some people can picture what it's going to look like, right? If you were to fold over x and then y, they can kind of picture where this is going to land and what it's going to look like. But particularly with origin, I find the visualization very difficult. So you can use points again. Choose a few important points. And for origin symmetry, the test was replace x with negative x and y with negative y. That's what you do here. Instead of xy, we're going to plot the opposite of x, the opposite of y. So 0, 3 is going to become what? 0, negative 3. The opposite of 0 is still 0. The opposite of 3 is negative 3. And then instead of 2, 1, I will plot negative 2, negative 1, the opposite of both. Instead of 2, negative 1, what will I plot? Negative 2, positive 1. Make them the opposite of both. So I'll do negative 2, positive 1. And then negative 3, positive 1. And negative 5, negative 1. And I just connect the dots. And I have the origin mirror of the original graph. Okay, so start talking about the graphing calculator. We're going to start super basic, so if you are already a little bit familiar with your calculator, please bear with me because some people have never even used it at all. And this is probably not going to help you. So, a brief summary. To turn it on, lower left button, right? It says on. Click that. To turn it off, you can press second, then the on button, because see how it says off in yellow? You press the yellow button and then that to make it go off. Okay. It also has an automatic shut off, so after a certain amount of idle time, it'll just shut off. Okay, accidentally press the mode button, right? Press the mode button by mistake, and now you're in this menu, and you're like, oh my gosh, how do I get out of here? You can get out of anywhere by pressing quit. So quit is right here, above mode. So you have to press the yellow button, then quit. Takes you back to the home screen. That's what we call this main screen where you do stuff, the home screen. Okay, so you can do general arithmetic in the home screen. Type 2 plus 3. 2 plus 3. And there's no equal sign. You use the enter button instead of equals, and you get 5. Now let's say you were trying to type 2 plus 3, but you typed 25 plus 3 by mistake. You have a little typo. You can use the arrow keys to go back into what you've typed, and then there's a delete button. Okay. But let's say you delete it, and it actually turns out you wanted to say 5 plus 43. Okay. So you can move the arrows, put it on the 3, and you can use the insert, right? INS is right above delete. I want to insert a 4. So you can use delete and insert to get things. And let's say you hit enter by mistake and you went, oh, you didn't notice there was a typo till after you hit enter. You can call up exactly what you previously typed in by pressing second and then the enter button. It gives you the previous entry. So if you hit second enter, it gives you the 2 plus 43. And you say, I really just meant 2 plus 3, delete that 4, enter. To square things, you can hit 7, and then there's a square button right here. And you can just press that, enter. Or you can do 7, and then use this little caret or hat thing to raise to an exponent. So you do 7 caret 2. And you use the caret for any exponent other than 2. There's a squared button, but there isn't a button for anything else. So if you want to do 2 cubed, you do 2 caret 3, enter. Okay, so we're down at about H. We're flew through the first ones. So we can find 2 cubed, and then hit clear several times because we like having a nice clean home screen. Okay. To find the square root of 9, the square root button is right above the squared button, but it's in yellow. So you do second square root, type a 9, and hit enter, and we get 3. If you want to do the cube root of 8, you have some choices. You can get there several ways. So first, you can just go to the math key. Math is in third one down on the left. And option 4 is cube root. So you choose that, you type in 8, and you get 2. Another option would be to hit the 3 first, type in the 3 for cube root, go to math, and option 5 is just an xth root. It'll take whatever root you want. You just have to type it in before you go here. So you hit xth root, and then you say of 8, 2. So if you want a fourth root or a fifth root, that's the route you go. There's only a special button for square root and cube root. Another thing would be to recognize that cube root is the same thing as what power, what exponent. One third, great. So you could do 8 caret, raise it to the 1/3 power. You just have to be careful. Make sure you put parentheses around the exponent. Otherwise, it's going to follow the order of operations, and it will do 8 to the first, and then divide the answer by 3. And you get 8/3 as the answer instead of 2. Okay. So now we're going to learn how to do absolute value. I'm going to clear my home screen out here. So to find the absolute value of a number, it's again in the math menu. Go to math. And then you can see within the math menu, there are 4 submenus across the top here. Go to number, the second one. The first option has absolute value in it. So it just has ABS parentheses. Choose that. So it doesn't have the like bars, or the 83 doesn't. I think some of the newer ones actually will pop up with bars, but this one doesn't. It just gives ABS parentheses, and you would type in -4, close the parentheses. So it's you're just saying take the absolute value of -4. Enter, it gives you 4, just what you'd expect. Okay, so what is 1/2 plus 1/3? Write it out on your paper, do it in your head. 5, 6. Yep. 1/2 is 3/6. 1/3 is 2 out of 6. So you get 5 out of 6. All right, so let's type into the calculator 1/2. The way you enter fractions is just with the division sign. 1 divided by 2 is 1/2. And I want to add 1/3. And it gives me a decimal, right? So, but I really would like a fraction because I think the answer should be 5, 6. I want to check that I did it right in my head. So to make this a fraction, you choose the math button, go to the math again. The first option in the math menu is to fraction. This arrow means change it to a fraction. So choose that, press enter, and you get 5 out of 6. So the answer, the decimal to fraction tool can save you a lot of time in like a test taking situation. All right, so let's type 4 plus 5. Hit enter. And say what I really want is the square root of that. And I don't want to retype the 9 because I'm lazy, right? Maybe instead of a 9, if you had like a 6-digit number, you don't want to retype it. And you want the square root of it. So you hit second square root. So you open the square root. And then to get this 9 to go in there without having to retype it, right above the negative sign, there's ANS in yellow. That gives you the previous answer. So you hit second and then ANS, and you get 3. It's very helpful when you're doing the quadratic formula. Okay, so if you do the whole thing under b squared minus 4ac, and then you say, oh, right, I want the square root of that. So you hit square root of the previous answer. Okay, now I already showed you second entry, so we'll do this for a little practice. We want to do -7 plus the square root of this whole thing. So oh, here's an important thing. Your calculator has different buttons for negative and subtraction. They're 2 different buttons. And even though we treat them the same when we do math, for some reason the calculator has 2 different buttons, and you can't interchange them. So you got to be careful there. So let's see, -7 plus the square root of 7 squared minus 4 times 1 times 12. And I get -6. Now, this looks like part of the quadratic formula, right? It looks like negative b plus the square root of b squared minus 4ac. So you also have to do negative 7 minus the square root, right, when you do the quadratic formula. So this is one place where second entry comes in really helpful. Second entry, you get the whole thing you just typed in, and then you can use the arrow key to just change that plus to a minus. And you hit enter and you get negative 8. Saves you a lot of typing. Now you do have to be careful with division problems. I already mentioned this with the 8 to the 1/3, but also something like 10 over 2 plus 3. What is the answer of 10 over 2 plus 3? 2. You add the 2 and the 3 first, and then you divide 10 divided by 5, and you get 2. So 10 over 2 plus 3 is 2. If I just type it in, 10 divided by 2 plus 3, I get 8. What did it do? Why did I get that? It divided by the 2 and then added the 3. It followed the order of operations. So you have to put in parentheses to tell it to add the 2 plus 3 first. So you have to do 10 divided by the quantity 2 plus 3. And then you get the 2 that you're looking for. All right, we're going to skip this. You can do the secret message on your own later if you want. Moving on to the graphing capabilities of our calculator. Okay, clear the home screen. So I want to get the calculator to graph this equation, y equals x cubed minus 3x squared plus 2. So the graphs that your calculator can graph are much more complicated than the lines or parabolas, which are probably the only things you've ever graphed before. Okay? So that's why we love having a graphing calculator. So the way to graph this is you press the y equals button in the upper left. If there's anything in there, you want to press clear to get rid of it. And we want to type in here x cubed minus 3x squared plus 2. So you're going to do x caret 3 minus 3x caret 2 plus 2. You can, yes. Yeah. Okay, now the coordinate plane is an infinite thing, right? It goes left and right infinitely, up and down infinitely. It's a gigantic infinite plane. So I have to tell the calculator where in the plane I want it to look at this graph. So the easiest thing to do is to choose a standard viewing window, which you get by pressing zoom and choosing option 6. That picks a window that goes from negative 10 to 10 in x and negative 10 to 10 in y. So you see the origin and 20 units of x and 20 units of y. So, but let's say, what I'm really interested in is this area here. Maybe I want to make sure I can see the x-intercepts and this turnaround point and this turnaround point. So I just want to look at this bit here. So maybe I don't have to, I can get rid of all this empty space to the left and empty space to the right and some of this space above and some of this space below. So how far left do I want to look? How many tick marks does it look like? 1, 2, maybe I could just go to -3. And for in the positive direction, and maybe 1, 2, 3, 4, -3 to 4. So the way I change it is this window button. You choose window right next to y equals. And I'm going to change x min and x max. Instead of looking -10 to 10, I'm going to go from -3 to 4. And then just press graph again and see what that does for us. So that's good. I got rid of a lot of the extra space to the left and the right. I'm going to get rid of some stuff above and below now. So maybe I only need to go down to like 1, 2, 3, -3, and I could go up to +3. So use the arrows, you go down and change y min and y max from -10 to 10 to -3 to 3. Now, personally, I never change anything else. X scale, Y scale, and X res, you don't ever need to change. Graph. And then this graph shows a lot more detail of the maximum and minimum points that I was interested in. And you can see the x-intercepts a lot better. So the way you zoom, like let's say I'm really just interested in this x-intercept. I want to know what that is in particular. So you can choose zoom. I like zoom box, which is option 1. So a cursor appears in your screen and you can just create a box with it. So put it anywhere you want. It's going to be, wherever you put it is going to be a corner of your box. I always put it in the upper left. And then once I have it where I want it, you press enter. And then you can move down and over to create a box around your point of interest. And then it's going to take this box that you made and blow it up to be the whole screen. Just press enter again. So that's my favorite way to zoom. I would do that if you ever need to zoom in. Okay, so let's see. I'm going to skip these questions and move on to question 4. So if you're in the graph, you can either quit or press clear, and either one gets you back to the home screen. So your calculator has this limitation in that to graph an equation, it has to be in the form of y equals something with some x's in it. It has to look like this because this is the only thing your calculator can accept. It has to be in the form y equals some stuff with x's. Okay. So how can we graph the equation x times y equals 5 on the calculator? Yep, you got to solve for y. So I'm going to clear what's in here now. And I'm going to solve this thing for y. So I would do 5 divided by x. And I didn't point out earlier, the x key is right next to alpha. It says xt theta n. For our purposes, whenever you press it, it's going to give you an x. You can also do alpha x, yep. So let's see what this looks like. We'll start with a standard window, and you get that by pressing zoom 6. And that gives you the -10 to 10, -10 to 10. Fancy picture. So that's a pretty decent window. We can just leave it like that. So in your groups, I want you to try to graph x squared plus y squared equals 9. Okay, let me just get you started here. So I have x squared plus y squared equals 9. Before I can do anything with the calculator, I have to solve for y. So I'm going to start by subtracting x squared from both sides. Then what do I do? Square root. So y ends up being square root of 9 minus x squared. But if you wrote that answer in a quiz, I would take off a point. Why? Plus or minus. Plus or minus. Okay. So you actually have to graph 2 things to graph this. You put in y1, the square root of 9 minus x squared. And in y2, you have to do negative the square root of 9 minus x squared. Yes, but you can't take the square root of each one separately. Yep. So yeah, let me just, little review. Square root of 9 plus 16. That's the square root of 25, right? Which is 5, and not 3 plus 4. Okay, so you can't do the square root of each one separately. So I go to my calculator, go to y equals, is anything there, clear it. You do the square root of 9 minus x squared. And then I want negative square root of 9 minus x squared. Start with zoom 6. And what does that look like? It looks like a misshapen circle. It looks like an ellipse, but it's not an ellipse, it's a circle. Why does it look like an ellipse? Nope, I wrote them both in. I put them both in. I put y1 is the positive one and y2 is the negative one. So the circle looks misshapen because what I'm looking at is a rectangle, right? So I have more distance along x than I do along y. Yet I put negative 10 to 10. I put 20 units in both of them. So the scales are different, right? What is 1 unit is different in the x direction than the y direction. Because I had to fit 20 units here, left to right, and 20 units here, top to bottom. So my units in the top to bottom are smaller than they are left to right. You can even tell just by looking at the tick marks. The tick marks on the x-axis are further apart than the tick marks on the y-axis.
So it's actually a perfect circle.
It is a perfect circle. The way to see it is use zoom, choose option 5, which is square, zoom square. It'll just square things up, make the units the same, and now it looks like a circle. And now you can see the tick marks are the same length on the x and the y axis. So that can be helpful sometimes, zoom square. And then maybe you don't want to look at, I mean, there's a lot of empty space in there, so you could go in and change the window. And window finding is a bit of an art. It takes a lot of practice, takes a lot of trial and error, trying to find a good window. We are going to continue working with the graphing calculator and graphing things next class. So we'll get some more practice then.